Hello grade 11 students. In this lecture we're going to start by a new objective, which is continuity. So we're going to talk about the continuity of a function and the derivative of a function. Let us first of all look at this figure. As you can see, or the graph, we can see that this graph is increasing from minus infinity to a certain point, then it increased to plus infinity. So we say that f is decreasing from minus infinity to minus 1. So for minus infinity minus 1, we observe that f is decreasing, then the derivative is negative. So if I have a figure, I can tell if the derivative is negative or positive, and if I have the derivative, I can tell that the function is decreasing or increasing. So the function, as you can see, just a second, okay, so the function here is decreasing. That means the function or the derivative is negative. So at this point, which is minus 1, minus 3, it's the minimum point of the function. So the function decreased from plus infinity to minus 1, minus 3, then it increased to plus infinity. Okay, so this point here, we call it the minimum point, and at this point exactly the derivative is equal to 0. Okay, so if you replace minus 1, minus 3 in the derivative, you will get a 0. So this is a root. This is a root for the derivative. Okay, so till now we know that from minus infinity to minus 1, the function is decreasing, then the function is negative, and from minus 1 till plus infinity, the function is increasing, then the derivative is positive. So if you look here at the table of variation, definitely you will be having this table of variation where we have minus 1 as a root for the derivative. Later on I will teach you how to find the root, and it's minus 1, minus 3. The derivative between minus infinity to and minus 1, it's negative, so the function is decreasing. And between minus 1 and plus infinity, the derivative is positive and the function is increasing. So let us see an example of how does the sign of f of x affects the sign of, or the sense of f of x. As you can see here in the table, we have from minus infinity to a, to point A, any point A, okay, the derivative is positive. What does that mean? Means the function is increasing. Between A and B, the derivative is negative, means the function is decreasing from its maximum to its minimum, to B. Then from B to plus infinity, the derivative is positive, then the function is increasing again. So in this function, we have a maximum and a minimum. The maximum is A and f of A, as you can see here, and the minimum is b and f of b. So when the function is increasing, the derivative is positive. When the function is decreasing, the derivative is negative. But how do I find the sign? First of all, we have the function. In order to study the sign, I have to find its derivative. So what's the derivative of 2x squared minus 4x plus 1? It's 4x minus 4. Great. After finding the derivative, you have to do something which is called study sign. So what do I do? Aside, we write study sign. What does study sign means? Study sign means you have to put the derivative, I mean f prime of x equals to 0, and try to find a root. Okay, so after finding the derivative, which is 4x minus 4, we put it equal to 0. 4x minus 4 equals to 0, then x equals 1. So this is a root, so we put it on the table. So the domain of the function is from minus infinity to plus infinity, and we put the root of the derivative. You know that we have before the root opposite, same. A is positive, oh sorry, A is positive. We look at the derivative. Means we have minus plus. So the derivative, we have minus plus. So the derivative is negative, means the function is decreasing. The derivative is positive, means the function is increasing. But now, how do I calculate this number here? Suppose that this number is not found. How do I calculate? I replace 1 in the function because I'm calculating it f of 1. Okay, so I place 1 in f of x, so I got minus 1. So 1 minus 1, it's the local minimum because the function is decreasing, then increasing. Let us take another example. We have the function f of x, x plus 1, x minus 1. So the domain of definition is minus infinity 1, 1 plus infinity. So let us find its derivative. The derivative of f of x, it's u over v, which means I have to calculate u prime v minus v prime u. Now the derivative is minus 3 over x minus 1 squared. But you know that x minus 1 squared, okay, it's positive for every x. Okay, great. So the denominator is positive for every x. And the numerator, it's only minus 3. So if you study the sign, if you put it f prime of x equals to 0, you will never get a root. Okay? So what do we have? Minus 3 above, which is negative. X minus 1 squared below, which is positive for every x. So the sign of the derivative will be negative for every x. Which means, in this case, in the table of variation, we put at the top the domain, minus infinity, 1, plus infinity. We put 1 shaded because it's condition. But there is no root to put on the table. But I know that the derivative is negative for every x. So minus means the function is decreasing from minus infinity 1. And it's also decreasing from 1 to plus infinity. So we say that f is strictly decreasing over its domain. Why do we say this? Because it's decreasing for every x. Let us do the third example. We have the function x cubed minus 3x plus 1. This function is also from minus infinity to plus infinity. We do the derivative. What's the derivative of x cubed minus 3x plus 2? It's 3x squared minus 3. Now when we put the derivative, when we need to do study sign equals to 0, then we have two roots, 1 and minus 1. We put them on the table, minus 1 and 1. Both of them are roots. So to the sign, same, opposite, same. So plus minus plus. So this is the derivative. We are done from the derivative. We can guess the sign of f of x. It's increasing, decreasing, then increasing. But how do I calculate the 4 and the 0? How do I calculate the 4 and the 0? As I said before, you replace minus 1 in f of x. So we calculate f of minus 1 and we calculate f of 1. So we get 4 and 0. So this function, it has a maximum minus 1, 4, a minimum 1, 0. Okay, and we know that f prime of minus 1 is 0 and f prime of 1 is also 0 because they are roots for the derivative. I wish that this lecture is easy. So starting from now on, we will do a complete question starting from the domain, limits, study parity, oblique asymptote, study the relative position of oblique and function, find the derivative, study the sign of the derivative, then we construct a table of variation. The last thing will be how to draw the curve. So the next lecture is going to be about the most important thing, which is how to draw. After gathering all this information, we can finally draw the curve of the function.